In simple terms, AI or artificial intelligence refers to computer systems or programs that can perform tasks that typically require human intelligence. These tasks can include understanding language, recognizing images, making decisions, and learning from experiences. AI aims to mimic human thinking and problem solving abilities, allowing machines to perform tasks autonomously or assist humans in various activities. Many people are curious about how AI works. Let me explain it now. Artificial intelligence AI works by using algorithms and computational models to mimic human intelligence. Let me tell you details on how it functions. 1. Data collection. AI systems need data to learn and make decisions. This data can be anything from images and text to sensor readings and user interactions. The more data an AI system has access to, the better it can learn and perform its tasks. 2. Data preprocessing. Before feeding the data into the AI system, it often needs to be cleaned and organized. This step involves removing any noise or irrelevant information, standardizing the format, and preparing it for analysis. 3. Algorithm selection. Depending on the task at hand, different AI algorithms are used. For example, machine learning algorithms like decision trees, neural networks, or support vector machines might be employed for tasks such as image recognition or language translation. 4. AI algorithms and models. AI algorithms serve as the core of AI systems. These algorithms can be categorized into different types, including machine learning, deep learning, and symbolic reasoning. Machine learning algorithms learn patterns and make predictions or decisions based on the training data. They can be further classified into supervised learning, unsupervised learning, and reinforcement learning algorithms. Deep learning is a subset of machine learning that uses neural networks with multiple layers to process and learn from complex data. Deep learning has been successful in various domains, including image and speech recognition. Symbolic reasoning involves representing knowledge using logical rules and manipulating symbols to perform tasks like problem solving or logical deduction. 5. Model training. During this phase, the AI algorithm is fed with the prepared data. The algorithm learns from the data, identifying patterns, relationships, and trends that allow it to make predictions or decisions. This process involves adjusting the internal parameters of the algorithm to minimize errors and improve performance. 6. Evaluation. After training, the AI model is evaluated to assess its performance. This evaluation helps determine how well the model generalizes to new unseen data. If the performance is not satisfactory, the model might be retrained with different parameters or additional data. 7. Deployment. Once the AI model has been trained and evaluated, it can be deployed to perform its intended task. This could involve integrating it into a software application, a website, or a hardware device, depending on the application. 8. Feedback and iteration. AI systems often operate in dynamic environments where new data and circumstances arise over time. Therefore, it's crucial to continuously monitor the system's performance and provide feedback to improve it further. This feedback loop involves collecting new data, retraining the model, and deploying updated versions as necessary. Overall, AI systems learn and make decisions by processing large amounts of data using sophisticated algorithms. Through iterative learning and improvement, they can perform a wide range of tasks, from recognizing faces and understanding speech to playing games and driving cars. Let me give you a very simple example of AI. Imagine you have a robot friend. This friend can learn new things just like you do in school. But instead of going to school, the robot learns from the information it gets from its teacher, which is called data. Now, let's say you want to teach your robot friend to recognize different animals. You show it pictures of cats, dogs, and birds, and you tell it which one is which. The robot looks at these pictures and learns to tell them apart by finding patterns, like how cats have whiskers and dogs have tails. This learning process is called training. After your robot friend has seen lots of pictures and learned from them, it can start recognizing animals on its own. So when you show it a new picture, it can tell you if it's a cat, a dog, or a bird based on what it learned from the old pictures. That's basically how artificial intelligence works. It's like teaching a robot to learn and make decisions by showing it lots of examples and letting it find patterns in the data. There are generally three types of AI. 1. Narrow AI, task-specific AI like virtual assistants. 2. General AI, human-like intelligence across various tasks. 3. Artificial superintelligence, intelligence surpassing humans in all aspects. So let me give some common applications of AI in daily use. 1. Virtual assistants. Voice activated virtual assistants like Siri, Alexa, and Google Assistant help us perform tasks such as setting reminders, sending messages, checking the weather, and playing music using natural language processing, NLP, and machine learning. 2. Social media. Its platforms use AI algorithms to personalize our feeds, recommend content, detect and filter out spam or inappropriate content, and analyze user behavior for targeted advertising. 3. Online shopping. E-commerce platforms like Amazon use AI to provide personalized product recommendations based on our browsing and purchasing history, as well as to optimize pricing, inventory management, and supply chain logistics. 4. Search engines. It is like Google use AI algorithms to deliver relevant search results, improve search accuracy, and provide features like autocomplete suggestions and voice search. 5. Navigation apps. It is like Google Maps and Waze use AI to analyze traffic patterns, predict travel times, and recommend the fastest routes based on real-time data. 6. Smart home devices. AI-powered smart home devices, such as smart thermostats, security cameras, and lighting systems, learn our preferences and habits to automate and optimize home environments for energy efficiency, convenience, and security. 7. Healthcare. AI is used in healthcare for medical imaging analysis, disease diagnosis, drug discovery, personalized treatment planning, and remote patient monitoring, improving patient outcomes and healthcare delivery. 8. Language translation. AI-powered language translation services like Google Translate use machine learning to translate text and speech between different languages, enabling communication across linguistic barriers. 9. Email filtering. Email providers use AI algorithms to filter out spam, organize emails into categories or folders, and prioritize important messages based on user behavior and preferences. 10. Ride-sharing apps. These apps like Uber and Lyft use AI algorithms to match drivers with passengers, optimize route planning, and dynamically adjust pricing based on demand and supply. These are just a few examples of how AI is integrated into our daily lives, enhancing convenience, efficiency, and personalization across various domains. Let me explain the trending topic of how ChatGPT works in today's world. It's an artificial intelligence language model developed by OpenAI, designed to understand and generate human-like text based on the input it receives. ChatGPT works by using a technique called deep learning, specifically a type of model called a transformer neural network. Let me simplify a breakdown of how it works. 1. Training data. ChatGPT is trained on a large dataset of text from the internet. This dataset contains a wide variety of texts, including books, articles, websites, and conversations. 2. Tokenization. The text data is broken down into smaller units called tokens. These tokens could be words, subwords, or characters depending on the specific tokenizer used. 3. Model architecture. ChatGPT uses a transformer architecture, which is a type of neural network particularly well suited for processing sequential data like text. The transformer consists of an encoder and a decoder. But in the case of ChatGPT, only the encoder is used for generating responses. 4. Training. During training, the model learns to predict the next token in a sequence of text, given the tokens that came before it. This is done by minimizing the difference between the predicted token and the actual token in the training data. 5. Fine-tuning. After pre-training on a large data set, ChatGPT can be fine-tuned on specific tasks or domains to improve its performance. Fine-tuning involves further training the model on a smaller data set that is more closely related to the task at hand. 6. Inference. When you interact with ChatGPT, provide a prompt or a question, which is converted into tokens. These tokens are then fed into the trained model, which generates a sequence of tokens as a response. The response tokens are then converted back into text and presented to you. 7. Response selection. The model generates a response based on the patterns it learned during training. The response is not a result of understanding or consciousness, but rather a statistical pattern matching process based on the input it receives. 8. Evaluation and improvement. ChatGPT's responses can be evaluated based on various criteria such as coherence, relevance, and correctness. Feedback from users can be used to improve the model through further training or fine tuning. So, ChatGPT works by learning patterns in text data and using those patterns to generate responses to user input. It doesn't truly understand the text in the way humans do, but it can produce responses that are often relevant and coherent based on its training data. The benefits of AI are manifold, ranging from increased efficiency and productivity to advancements in healthcare, transportation, and various other sectors. AI has the potential to revolutionize industries, streamline processes, and enhance decision making, ultimately leading to improved quality of life and economic growth. However, it's essential to ensure responsible development and deployment of AI to mitigate potential risks and ensure equitable access to its benefits for all. In conclusion, AI operates through complex algorithms that enable machines to learn from data, identify patterns, and make decisions or predictions autonomously. By mimicking human cognitive functions, such as reasoning and problem solving, AI systems can perform tasks ranging from natural language processing to image recognition with remarkable accuracy and efficiency. As AI continues to evolve, it holds the potential to revolutionize industries, drive innovation, and solve complex challenges. However, understanding the ethical implications and ensuring transparent and responsible AI development are crucial for harnessing its full potential while addressing concerns about privacy bias and job displacement.